Okay, we're into combinatorics and some advanced theorems. So the first one is called the pigeonhole principle. And if you go on YouTube, there's heaps of videos on the pigeonhole. They've got good graphics, but I'm just going to try to explain it without it. But you can certainly go onto YouTube and have a look. So the theorem is pretty straightforward. If you've got n plus 1 objects and you've only got n holes, you don't have enough holes for all the objects. So then some holes must contain at least 2. Okay, because you don't have to use all the holes, but there must be at least one of them that has at least 2 of them. Okay, so basically, if you have more objects than you have holes, then at least some of the holes must contain at least 2 of the object, and they could contain more because you could have empty holes. So the proof is by contradiction. If n holes had exactly one object, then you would have n objects. But because we said we had n plus 1 objects, you can't fit it, so that means that you can't have exactly 1, so there must be at least 2 in one of the holes. That's the theorem. How do you use it in questions? That's what the question is. Copy that and come across. Okay, so in a sock drawer, excuse me, there are 13 reds, 10 blues, 8 greens. How many socks must you take out to ensure you've got a pair of socks? Now you can use common sense. Basically, you've only got 3 boxes, 3 colors, which are the 3 boxes you can put things in. You got red socks, blue socks, and green socks. Okay, so you've got 3 boxes. So you need to put in at least 4 objects to get one of the boxes would then have at least 2. Like for instance, the worst case scenarios in the first 3 socks you get 1 of each. Okay, so you got 3. You've taken 3 socks out, but you could have 3 different colors. So when you take out the 4th object, you must have one of those 3. So the answer is you need 4 socks. Okay, so basically, if you've got 3 boxes, you need 4. Okay, you need 1 more to fulfill the pigeonhole. Okay, copy that and come across. Okay, this is a little bit harder, and have to use some ideas from previously. Okay, so 7 teams play 22 games. So how many ways can 7 be arranged in pairs? So that's a combination. So 7C2 is from the combination which you've already done. So we've got 22 different arrangements. Okay, of 7 teams in pairs. So once you've got 22 games, okay, you've only got 21 boxes, so you need 22 games. So then therefore at least 2 teams play twice, because you only got 21 boxes and you've got 22 games. Okay, so that's the end of that. Okay, copy that and come across. Okay, now we come up to a generalized excuse me, pigeonhole principle. And again, it'll make sense when you see an example. If you have m times n plus 1 objects are placed into n holes, then some holes must contain m plus 1 objects. Okay, so here's the proof. N holes contain n objects, then we have mn objects, but we've got mn plus 1 objects, so there's a contradiction. Okay, so if n holes contain m objects, you don't have enough objects, so one of the holes must contain m plus 1, must contain probably at least m plus 1 objects. Okay, so let's have a look at an example. I have 16 natural numbers. Prove that 4 numbers will contain the same remainder when divided by 5. Okay, so what sort of remainders can you have? Well, a number can be divided by 5 with remainder 0, remainder 1, remainder 2, remainder 3, and remainder 4. You can't have remainder 5 because if it's divisible by 5, there's no remainder, so we're back to here. Okay, so 16 numbers is the same as 3 times 5 plus 1. So we've got this idea of m times n plus 1 coming up. Okay, so if you've got 5 objects, okay, if you've got 5 holes, then at least 1 box will contain contain m plus 1, which is 3 plus 1, which is 4. So at least 4 numbers will contain the same remainder. Okay, so that's a little bit harder, but there'll be some examples in the textbook for you to look at. I think there might be one more slide. Okay, so this is not in the, I don't think it's in the, oh no, this is the book we're using. So Cambridge is the book we're using, so it's exercise 5H. Okay, that's it. Bye.